A man weighs 600 newtons. It means the weight of the person is 600 newtons. He runs up a staircase of total height 4 meters in 3 seconds. Again, it's a potential energy case. Height is 4 meters. And the time taken is 3 seconds. How much useful power is needed to do this? Okay, so we know that power is potential energy over time. So potential energy is mgh, or you can say weight into height over time. So weight is 600, height is 4 meters, over time is 3, 200. 200 times 4 is 800. So for this particular case, 800 watt power is required. 800 watt power is required. A a workman rolls a barrel of weight 800 newtons. This is weight. Up a plank of length 2 meters on a lorry. The back of the lorry is 8 meters. So height is 8 meters above the horizontal surface. So this is 8 meters. 8 meter is somewhere here. Okay. What is the work done on the barrel against gravity? Okay. So work done against the gravity appears as a potential energy. Potential energy is mgh. So mg is w and height is h. So weight is 2000 newtons and height is 0.8 newtons. So it would become 1600 joules. Number 54. Energy from petrol is used to operate an engine. The engine drives a generator which produces electrical energy. So energy from the petrol, whatever the mechanism was there, is given to engine, which is 400 joule energy is given to this engine. Out of 400 energy, 120 joules of energy is work done by the engine, and 120 joule of energy is given to generator. Generator converted that energy into electrical energy, and that is 100 joules. What is the overall efficiency? Like, we can start from here. This is our input energy. Input energy is 400 joules and output energy is 100 joules. So 100 divided by 400 is multiplied, like efficiency is output over input multiplied 100%, because the answers are in percentage form, so that's why. So 100 divided by 400 multiplied by 100%. So zeros are cancelled. So 4, this is 25. So which is 25%. So the correct option is this one. A single spring is loaded. This is a single spring which is loaded with 1 Newton force, 1 Newton weight. As you can see, the extension is 1 centimeter. You can see the load is then increased to 2 Newton's joules. Initially 1 Newton weight was there. This was the height. When it became 2 Newton, the height becomes like this. And then extension increased by 1 centimeter. Two springs are that are identical to the first one are put aside, like two identical ones. They are connected at both ends and at a 1 Newton, like this 1 Newton weight is hung on them. The load is then increased to 2 Newton. 1 Newton is then increased to 2 Newtons. What is the new extension X in the what is the new increase X in the extension? Now you can see The materials are same, so their K value would remain same. Spring constants are same. So when a 2 Newton weight was loaded with this spring, it generated 1 centimeter extension. Now the same weight is balanced by 2 springs. So this extension is divided between, like 2 Newton weight can generate a 1 centimeter extension. So when you increase the spring, the extension is equally divided. Extension is 1 centimeter for 2 Newton. 2 Newton can generate 1 centimeter. So when 2 Newton is held by these two springs, it is equally divided uh, between these two springs, and I think so. 1 divided by 2 would be 0.5 centimeter. The graph shows how the height above the ground on a bouncing ball changes with time. Now you can see, suppose the ball is here, it will have potential energy. When it goes in downward direction, its potential energy decreases and kinetic energy increases. At this point, before the impact with the ground, it will have maximum kinetic energy and minimum potential energy. Like when it impacts with ground, some of its energy is transferred to the ground, or and when it come in contact with Earth's surface, some of energy is converted into heat energy due to friction. Then it rebounds and potential increases, kinetic decreases, potential increases, kinetic decreases. This is the maximum point again for potential energy. Kinetic decrease, potential decreases, kinetic increases, and same happens here. Now if you see, initially the height is here, the energy was highest, and now the height is little lower than it. There is a difference of energy between the peaks, because some of the energy is lost at this stage when it collides with the Earth's surface. Similarly, some energy is lost here, some here, and some here. So this energy goes from here till here, and after some time it would become zero. So let's look at the possible correct option. The statement explains why the height of each peak decreases with time. The kinetic energy is converted into potential at each bounce. That's fine. But there is no explanation in it for decrease in peak, decrease in height of a peak. Kinetic energy is converted into thermal energy at each bounce to some extent. That's correct. The ball gains energy on each rock. The ball is wearing out. Wrong. So we have only one correct option. The diagram shows a battery operated motor lifting a block of wood at constant speed. It's a battery operated motor which actually lifts this wooden block. What is the overall energy change take place? So in a battery, there is a chemical which results chemical energy. and due to which the block is moving in upward direction. It means the wood is gaining gravitational potential energy. So chemical energy from the battery is responsible for the wood's kinetic energy. So this option is little easy. Four students exercise in a gym. Which student does the most work? Okay, so we know that power is energy or work over time. So power into time is work done. So here we have time is given and power is also given. So instead of power, we will insert the values from this part of the this table, and for time we have this area. So 250 times 50. So 250 times 150. Uh, 12,500. So 100 times 150 is 15,000. 200 times 200 is 40,000. And 250 times 30 is 7,500. So in case A, there is 12,500 joule work done. In second case, 15,000, third case, 40,000, and the last one, 7,500 joule work is done. So the maximum, which student does the most work is C. Which formula gives the efficiency of an energy conversion? Efficiency is useful energy output over total energy input. That's very simple. A 2 kg mass is moving at constant speed. The kinetic energy of the mass is 400. Mass is 2, kinetic energy is 400. What is the speed of the mass? That's very simple. We know that kinetic energy is half mv square. So kinetic energy is 400 joules. Mass is 2 and speed is unknown. So 2 is cancelled with 2. So v square is 400. So V equals 20 meter per second. A crane moves its load diagonally. It's a kind of repeated question in which we are already done with the B as a correct option because this is the height which is gained by this mass. Okay, the efficiency of electrical engine is 65%, means 0.65. It looks a kind of again a little repeated type of question in which one like the answer was I think so 7.8. Okay. In an hydroelectric power station, water from a reservoir falls down a long pipe before entering the turbine. The turbine then turns the generator. What is the overall energy conservation? Like in a reservoir, as long as water is there, it will have some potential energy. That potential energy is converted into kinetic energy because water flows, it will have some kinetic energy. That kinetic energy is given to turbines which convert them into electrical energy. So originally there is a potential energy. In a reservoir we have potential energy. That potential energy is converted. Okay, that is converted into electrical energy.